In this episode, we're talking about jobs for mechanical engineers, and we're starting right now. Hey 1% Nation, I'm Jake Voorhees, and welcome back to the 1% Engineer Show, where we empower young engineers to rise to the top 1% of their career. So if you're a young engineer and you want to be the best you can be, make sure you subscribe. This is episode 103, and in those videos, my most popular is what do mechanical engineers do? So I want to keep making more videos for those young engineers, because I also get tons of questions like, can mechanical engineers be an aeronautical engineer? And can a mechanical engineer do this or that? And most of the time, the answer is yes. These are all massive portions of the pie chart where mechanical engineers work. So I wanted to cover these and give you guys some more practical examples of where you could head with your mechanical engineering degree. So in this video, I'm laying out 5 types of jobs for mechanical engineers, and we're going a little bit more in depth of what that job might actually do, what you get to work on, and what that career may be like if you're going to choose that for the beginning of your career. All 5 of these are pretty good. What kind of mechanical engineer do you want to be? Comment below. And I put them in an order based on how many questions I get. Starting off with mechanical engineering job type number 1, which is automotive engineering. We're starting with this because so many hopeful mechanical engineers want to work on cars, want to work on vehicles. They know they want to be a part of the automotive industry. Automotive engineering is technically a part of vehicle engineering. This also is the case for, say, aerospace engineering or naval architecture. These are both branches of vehicle engineering. Automotive engineering involves several engineering elements like mechanical, electrical, electronic, software, computer, and safety engineering. But it comes down to really just 3 things around automotive engineering, which is designing new products or modifying existing ones, troubleshooting and solving engineering problems, and the third part is planning or designing manufacturing processes. What are some of the products that you might be working on? Of course, it could be a machine part of an engine of a car. It could easily be a piece of a body, or you could be designing anything inside of the car, or even anything in regards to the emissions or the fuel system. For an automotive engineer, troubleshooting or solving engineering problems would be specific to that company. For example, Firestone, the tire company that had an issue that killed people, must have had all of their engineers on deck to solve that issue at the time. Or for example, when Tesla is releasing a new product like that crazy truck they announced 6 months ago, they have engineers who are trying to make sure that they can figure out this truck before they do the market announcement. Outside of a very specific problem for that company that you work for as an automotive engineer, you most likely have a lane of your expertise within automotive engineering that you work on. Some of these examples include safety engineering. These engineers would work on the brakes and the airbags and the anti-skid and anti-lock systems of the vehicle. You could work on fuel efficiency and emissions. This is very important in automotive engineering, especially today. This would even include the tires, how the engine operates, the types of fuel that is used, the aerodynamics of the vehicle, and other aspects around fuel efficiency. NVH engineering. This applies to noise, vibration, and harshness. Harshness is the subjective quality of how humans interpret noise or vibration. You could also work on the vehicle electronics. You could focus on vehicle performance, shift quality, durability, drivability, cost, program timing, and more. Whatever your interest is within automotive engineering, you can do that for your career as an automotive engineer. Mechanical engineering job type number 2 is aerospace engineering. I get so many questions about the path to be an aerospace engineer because most universities don't have an actual dedicated aerospace engineering program. There are plenty of universities that do, and that is typically their lead program within their school. They're known as an aerospace engineering school. And so the path to become one isn't always clear. But again, guys, the theme in this video is that a mechanical engineer, if you choose the right internships, if you choose If you choose the right internships, if you take the right tech electives, if you build the right relationships, you can enter the aerospace engineering career for your entry-level job, but you have to make the right steps. Aerospace engineering is the primary field of engineering concerned with the design, development, testing, and production of aircraft, spacecraft, and related systems and equipment. The field has traditionally focused on problems related to atmospheric and space flight with 2 major overlapping branches. The first one is aeronautical engineering, and the second one is astronautical engineering. Aeronautical engineering focuses on the theory, technology, and practice of flight within the Earth's atmosphere. These are typical planes, jets, things that do not go into outer space. And oppositely, astronautical engineering focuses on the science and technology of spacecraft and launch vehicles. So if you want to get a job at Boeing, for example, then aeronautical engineering is for you. If you want to get a job at SpaceX or NASA, then astronautical engineering would be the focus. But the entire field, either one of these, is considered aerospace engineering. So I'll be using that term from here. Aerospace engineers develop leading edge technologies and integrate them into aerospace vehicle systems used for transportation, communications, exploration, and defense applications. This involves the design and manufacturing of aircraft, spacecraft, propulsion systems, satellites, and missiles, as well as the design and testing of aircraft and aerospace products, components, and subassemblies. Now that you know what aerospace engineers do, where do they work? Aerospace engineers work at systems and software suppliers, corporate labs, government labs, and universities. The skill set of an aerospace engineer is extremely broad and multidisciplinary, and the experience of aerospace engineers as systems architects and engineers allows them to make contributions in many diverse sectors. Mechanical engineering job type number 3, biomedical engineering. Biomedical engineering is another type of engineering like aerospace engineering in the sense that not every core engineering college will have that program. Universities that have a good healthcare program, nursing, and medical schools are more likely to have a fusion of their engineering college with their medical college, and they have a biomedical engineering program. Biomedical engineering is the application of the principles and problem-solving techniques that combine engineering to biology and medicine. This is evident throughout healthcare, from diagnosis and analysis to treatment and recovery, and has entered the public conscious through the proliferation of several technologies such as implantable medical devices, like pacemakers and artificial hips, to things like futuristic technologies such as stem cell engineering, 3D printing of human organs and body parts, and beyond. Biomedical engineering focuses on the advances that improve human health and human health care at all levels. Biomedical engineering differs from other engineering disciplines that have an influence on human health in that biomedical engineers use and apply an intimate knowledge of modern biological principles in their engineering design process. Aspects of mechanical engineering, electrical, chemical, and material science, along with mathematics and computer science, are all integrated with human biology in biomedical engineering to improve our health. Whether it be an advancement of prosthetic limbs or a breakdown in identifying proteins within cells, whatever it may be, this is what BMEs are focused on. There are many subdisciplines within biomedical engineering, including the design and development of active and passive medical devices, orthopedic implants, medical imaging, biomedical signal processing, tissue and stem cell engineering, and clinical engineering, to just name a few. What would you actually do as a BME? There are opportunities in industry for innovating, designing, and developing new technologies. In academia, furthering research and pushing the frontiers of what is medically possible, as well as testing and improving new diagnostic tools and medical equipment. Many biomedical engineers are working on cutting-edge medical technologies for a startup or go into entrepreneurship themselves. That's what I did, guys. I left the civil engineering industry behind, and I'm a part of a startup now. Mechanical engineering job number 4, software engineering. Yes, you can be a software engineer as a mechanical engineer. There's lots of different types of engineers and math, STEM, engineering-like types of college students and professionals that end up in a programmer, computer science, software development, software engineering type of role. If that's what you want, you can do it. Software engineering is the systematic application of engineering approaches to the development of software. Software engineering is a branch of computer science. Don't get this confused, guys. Software engineering develops software. Computer scientists may never do that. They could be a data scientist, they could be an analyst. They may never actually build or make something new. That's what's cool about engineers. We build stuff, we make stuff. Engineers by nature are tasked with developing solutions to problems or creating more effective processes by using tools already in existence. By extension, software engineers often find themselves creating new software by utilizing existing languages or established practices already in use. Software engineers have extensive knowledge of programming languages, software development, and computer operating systems, and they apply engineering principles to software creation. By applying these engineering principles to every stage of the development process, from requirements analysis to the software process, they can create customized systems for individual clients. There are many types of softwares that a software engineer can develop, such as operating systems, computer games, middleware, business applications and network control systems. Changes in technology and new areas of specializations keeps this profession evolving at a rapid pace. This is why there's a huge draw for software engineering. It's the most trafficked engineering type on the internet. I probably need to make more software engineering videos. Software engineers can be divided into two categories: applications engineers and systems engineers. Applications engineers create or adapt applications for business and organizations by analyzing the end user's needs. They will design, build, install, and maintain these applications or programs. Systems engineers coordinate the creation, maintenance, and growth of a business or organization's computer systems. They coordinate each department's needs, suggest technical direction, and set up any networks that link up computers with the company. Okay, on to the last one. Mechanical engineering job type number 5 is product engineering. Product engineering refers to the process of designing and developing a device, assembly, or system such that it can be produced as an item for sale through some production manufacturing process. Product engineering usually entails activity dealing with issues of cost, producibility, quality, performance, reliability, serviceability, and the intended lifespan of that device and other user features. These product characteristics are generally all sought in the attempt to make the resulting product attractive to its intended market and a successful contributor to the business of the organization that intends to offer the product to that market. It includes design, development, and transitioning to manufacturing of the product. The term encompasses developing the concept of the product and the design and development of its mechanical, electronics, and software components. After the initial design and development is done, transitioning the product to manufacture in volume is considered part of product engineering. Things that you may be responsible for as a product engineer include: you may define the yield roadmap and drive the fulfillment during ramp-up and volume production, identify and realize measures for yield improvement, test optimization and product cost ability methods, define qualification plans, and perform feasibility analyses. Product engineers are the technical interface between the component development team and the production side, which is the front end and back end, the actual software side, especially after the development phase and the qualifications when the high volume production is running. Product engineers improve a product's quality and secure the production reliability by balancing the cost of tests and test coverage that would impact the production fall off. So I hope you enjoyed this video, guys. 5 different job type examples that mechanical engineers could do. Thanks again for watching the 1% Engineer Show, guys, where we empower young engineers to rise to the top 1% of your career. So if this is you, make sure you subscribe. If you have a question about anything in your engineering journey, leave it in the comments below. We have a Facebook group with almost 1,800 young engineers who talk about their problems and what they're up to right now, especially during this crazy pandemic today. So guys, make sure you find that link in the description. If you want access to the 1% Engineer Kit, which is 5 ebooks I've compiled for your engineering success, it's free. Follow the links below. Thanks again, guys, and we'll see you again in another video. Bye-bye.